Good, so let's get started. I'd like to introduce our tutorial speaker, Patrice Roulet. Based in Canada, Patrice heads ImmerVision's engineering team. Back in 2000, in France, after completing his master's degree in image processing and computer graphics, Patrice joined the INRIA and contributed to the research in robotic surgery simulation. In parallel, he co-founded ImmerVision, a company dedicated to 360-degree optics and imaging technology. Beyond technology, Patrice believes that innovation is propelled by human beings, partnerships, and alliances. He has collaborated with a large ecosystem of partners in the optics industry, like Fujifilm, CBC Computer, Tamron, and Colen, and in the silicon industry, like Marvell, Intel, Qualcomm, Sony, Samsung, HiSilicon, NXP, and ImmerVision. Patrice, it's over to you.
Thank you very much. Thank you very much. I'm really happy to be here. It's really an honor for me, and frankly speaking, I'm more a guy from the industry, and when I present something is to people, and I'm used to interact with them. So don't be shy. Any question, any remarks, any interaction you want if you want to tell me something, I mean, stop me. Okay, no problem. I would like to do this very casual. We have a long conference. The CS show was really intensive, plus all the material that you had during the conference. So be interactive and don't hesitate, don't be shy. So basically, as Tom mentioned, I'm more from the industry than from the academics. I created this company with some friends 14 years ago with the idea that 360 will be everywhere. And it's starting to happen. So I don't know if you had a chance to walk the CES show. Maybe some of you have seen a lot of 360 devices, one camera, multiple cameras. So my goal during this talk is really to show you different use cases and what is the future of this technology, what the technology can do now, and what is the possibility open by this new medium. Okay? I will just skip this slide because it was very well done by Tom. And so I would just like to start by this device. So back in 2000, almost at the time when we found ImmerVision, Japanese phone manufacturer released this device. So it's a combination of the first time that we combine in a consumer hands a modem and a camera, opening a wide range of possibilities that you well know now. So video chat, video conference, selfies, and that brings to the industry, the consumer electronics industry, so new devices plus new way to communicate. Like I'm sure that you are big fan of Facebook, YouTube, and others. So basically, this innovation, putting together a camera and a modem, changed the full ecosystem in the consumer electronic industry. And now we are starting a new revolution with the VR. So you cannot in your VR now, so different OEMs create their solution. But what's happened now is the industry is facing of the lack of content. There is super professional solution to create immersive VR content, but there is it's not true now, but there is not just a few ways for a consumer to create VR contents. So at that stage, I would like to show you what are the possibilities of the 360-degree technology. So basically, when we started to promote the 360, the first application was surveillance. So putting a wide-angle lens in a camera, capturing the full environment from the ceiling, and then have the full situational awareness of the area. But starting from this, many other applications was developed. So now you have sports cam with wide-angle lens, you have drones with wide-angle lens, you have wearables, On the other side, on the display, you have some application and head-mounted display to explore and to be immersed in this content. Other type of 360 camera is the body camera, the live logging camera. And recently, we miniaturized the technology to go super small in a smartphone, or super high resolution with the 6K camera, 360 camera for broadcast. All those devices can use one camera or multiple camera to capture the full immersive content. For example, that's the content captured by a 360 camera, one single lens with a full frame sensor, ready for broadcast. When I say ready for broadcast, means that the camera is a 6K camera, and then when you dive inside the image and you explore the content like this, you have 2x zoom possibility and broadcast the event at 1080p. So basically, the company doing this, C360, provide two user experience. The first user experience is for the producer, the broadcaster, so on site. They use the camera and they create new way to capture the event and even go back and replay the action like this and creating new traveling and new way to display the content. But in the same time, they create also what they call the second screen experience. So basically, you are in front of your TV, you look at the race or the NFL game, but in the same time on your tablet, you can explore the action in a different way, different angles, and select the point of view that you are interested in. That's what 360 brings to the broadcast. So basically, one new way to capture the event and to create different effects and traveling for the producer, and the second use case is ready for you, the consumer, exploring the content and creating more interaction. This interaction can be done on a PC like this, on a tablet, on a mobile phone, or even on the head-mounted display. Imagine having this camera seated at the best place of the house. I mean, and you can, with your head-mounted display, go and see different games, and for the producer, it's really interesting because they can sell the seat many times. So that is, I would say, the super professional way to capture 360 contents. But on the other hand, the goal is also to bring the technology in many different other devices. For example, I mentioned at the beginning, the beginning of the technology was the surveillance. So that's another application in the surveillance industry. Video conference also is a big thing. So imagine a laptop with a 360-degree lens on the screen. So you can select the view, look at the different person, and even with an head-mounted display, you can be sit at the place of the laptop in the meeting room. So that's what the 360 technology bring to the market. Is really a way to capture immersive content, even if it's not the super. I would say even if it's not achieved the presence quality, means you feel everything, the 3Ds, plus the immersion, plus the wind, and plus all your sensor feed with the content, but at least you have I would say a light immersive experience. So starting from all those different devices capturing 360 content, how to create, share, and experience this content. There is solution for regular video and regular cameras. Means you capture a video, and you send this video through YouTube or Facebook and you can display it. But there is no complete solution right now to create, share, and experience the immersive content. So just a little word about the creation. So that's an history of the panoramic lens evolution. So at the beginning, the first type of panoramic lens was a catadioptric lens. So basically, it's a camera with a mirror on top of it. So the camera captures the image reflected by the mirror. After that, in the 60s, the fisheye lenses appear on the market. And this lens was the first wide-angle lens to capture the full environment, but with some, I would say, drawback for certain application. And that gave us the idea of the panomorph technology. So we noticed at that time that the fisheye lens, even if the fisheye can capture the full 360 environment, you have in the fisheye a linear repartition of the resolution, means at any place in the field of view, the pixel density is the same. So if you capture the full action, you have all the objects at the same resolution. Even sometimes with certain fisheye, the resolution drop in the periphery of the image. So that's why we invent the panomorph technology. So the goal of the panomorph technology is really to design the lens according to the application needs. Let me pick a few examples. So for example, in surveillance industry, when you put the camera on the ceiling like this, you really need to have the best resolution on the periphery of the field of view to increase the magnification possibilities of the camera in periphery. At the opposite, when you do an endoscope and you want to capture 360 to be sure that the surgeon has the full view of the body cavity, but the main interest is in the middle where he do the surgery. So that's give the idea of the panomorph technology. So each time for different application, we design the wide-angle lens to fit the application requirements. And so there is an innovation inside with that we call distortion control, and that's the image on the right. So basically, compared to the fisheye, we play with the distortion to magnify some area of interest. And the other innovation is what we call anamorphosis. So basically, driven by the screen, the sensor, the image sensor are not square. They are 16 by 9 or 4 by 3. They have 16 by 9 or 4 by 3 aspect ratio. And with the anamorphosis, we design the lens to fit the sensor aspect ratio. So basically, with those two innovations, we combine that together to customize the distortion to magnify some area of interest. Any question up to now? Do you have some question about the beginning of the presentation? Okay. So basically, with this new lens technology, we can create tons of different design depending on the application. If the lens go on a broadcast camera, on a surveillance camera, or on a mobile phone, the distortion pattern is different. So you can see on the slide the three main trends of distortion patterns: the emphasis in the middle, endoscopy, the emphasis in periphery for surveillance, or even the emphasis in what we call the mid-zone. The mid-zone. We realized that for the smartphone application, when the customer holds the smartphone, he always keeps the smartphone at around 45 degrees. So this 45 degrees is where you need the best resolution. You want to capture the full bubble in front of the device, but you need to have more pixel per degree in this area. So basically, when you hold your phone like this, or if you put your phone on the table and you want to capture the full audience around the table, this 45-degree mid-zone is where you need the best resolution. So each time we design a panomorph lens, we design the panomorph lens with the application in mind, what would be the use case, and we work with the OEM or the product manufacturer to design the lens according to their needs and their application. That's also this is the difference in resolution when we do when we add an anamorphic component inside the lens to stretch the image by optical design and to cover more pixels on the sensor. So combining both, we create different design. There is tons of possibilities of different design for different applications. Now, all those lens design are different. So mobile phone 1 and mobile phone 2, sports camera, video surveillance camera, broadcast camera, all of those has different distortion inside. And when you correct the image and you apply the distortion correction, you need to know the pattern of the distortion to apply the proper correction. I will explain more about this during the tutorial. This slide showed the benefits to have more pixels per degrees in the area of interest. So basically, you remember the application when your smartphone is on the table with a panomorph lens on it, or a fisheye. So as you can see, in the fisheye, the size of the head of the person here are really small because we hit the periphery. In this case, we designed the lens to focus on the person's head. So basically, we have more pixels to cover the area of interest. And after that, when we process the image and we do what we call the dewarping, so flatten the image and correct the distortion, we have more pixels at the input, so we have a better quality at the output. And from all of those panomorph lenses, different lens, different distortion profile, we can create also different dewarping projection depending on the application as well. From the basic perspective projection, exploring the content and doing the 360 navigation, up to specific projection for computer vision algorithm, for example. So that's really what we do. We combine the optical science and the image processing at the early beginning. Instead of, for example, purchasing a lens, measuring the lens, and then determining what is the parameter of the algorithm. With the panomorph technology, what we do, we take the user needs, the OEM spec, and we create the lens and the image processing algorithm together to be sure that the user will have the best experience in 360. So starting from this, all those different lenses, we need to find a way to share this content. It's not, I would say, a regular content. So now, if you take your smartphone or your action cam, you record a video, you push the video on YouTube, there is no processing, means YouTube display what you record. With the immersive content, you need to know the parameters of the capture to display it on the proper way. So you need to know the distortion of the lens, you need to know the orientation of the device, you need to know by which device it was taken to be sure that when the user will navigate in the content, you will dewarp the image on a proper way. So we have to invent a new way to share this new content. So there is some initiative right now. So I'm sure you have seen on Facebook and YouTube some 360 videos. And those 360 videos are pre-processed content. So means the camera capture the wide field of view scene. They convert the image in a specific projection and to be compatible with the dewarping engine of YouTube or Facebook. During this processing, you consume energy on the device, on the computer, plus you reduce or you destruct the image quality. So the approach we have in mind and what we propose is to keep the original content and process it at the display stage, at the display, on the display side. So in this case, you have to find a way to pass the parameters through the different cloud application and different file format and video transmission without losing this metadata. So the idea we have and what we propose to the different OEMs and application makers is to pass the content directly inside the image. No matter if you use BMP, JPEG, H.264, H.265, you have inside the content the parameter required to do the dewarping. So in this case, you can see on the slide, so in the image, the device had 4 QR codes on each corner of the image where there is no light, where there is no the pixels are black. And so we use this space in the image to encode the dewarping parameters. So in this QR code, there is the lens distortion parameters, the module calibration, because when you do the assembly of the lens on the sensor, there is some tolerance, and you need to know the position of the image, of the lens compared to the sensor. The 360 navigation experience, so means how the device want to be displayed by the viewer, by the player. And also the device orientation. In the example you have seen at the beginning, so the NASCAR or the surveillance, the lens was mounted on the ceiling or on a specific place with no movement. But that's not the case when you have a consumer device, I mean a sports cam or a mobile phone. The user can move in any direction. So I have an example of that, and I will show it. So this is for illustration of mass speech. For sure, it's the movement are really crazy, because it's like a kid doing a lot of movement, filming the action with a mobile phone like this. If you look at the raw content exported by the device, so there is the 4 QR codes, and in real time, the QR codes are moving. The information inside those QR codes are, so the lens distortion, the calibration parameters, plus all the information about the phone sensors, so gyro, compass, accelerometers, GPS, and using those information, the application on the other side, the player, could be a YouTube player or a VR player on the mobile phone, read those marks and create the proper user experience. So in this case, for this example, what the player do is the image stabilization, I mean point of view or point of focus stabilization. Knowing the position of the device, you can focus in one direction, no matter if the part of the field of view, the cursor, for example, go out of the field of view because it's not recorded anymore. Your view stay focused on a certain angles. And that's important when you display the content on a tablet, but it's much more important when you have this content inside the VR display. Because if I would have displayed the image without stabilization, you would feel dizzy in 10 seconds. So that's the ideas that we bring to the industry for free, giving them the possibility to share the immersive contents. And so we are working with the device manufacturer to include a piece of software on the device to encode the marks inside the video. And we are working also with the VR player or immersive players to integrate this technology on the other end, allowing at the end broadcast directly the content without transformation on the device or on the computer, but doing the transformation just before the display. That's where are the horsepower on your mobile phone or on your PC. So as soon as you have shared the contents and you have all the parameters, how to experience it. So basically it's what I already mentioned. It's what we call that the de-warping. So the way to capture this content and create different projection according to the user experience you want to create. So you have access to the full 360 sphere, and you can create different projection depending on the application. So for example, on the top left corner, you have what we call the group selfie. So basically capturing the alpha sphere in front of the mobile phone. And from this sphere, you can create a banner like this, a 180-degree selfie.
So that is much more less expensive. So that I believe the price point is much higher. There also they are actually targeting it for sports stadiums and stuff like that. So what is your price point? If, for example, for B2B kind of a thing.
So you mean I did not understand the beginning of the question. So the price point of this technology compared to? Could you elaborate a little bit more about the technology they have, just to make me understand?
They use a lot of lenses. They use like about 8 or 16.
Cameras stitched together.
Yes, and they stitch together, and their main focus is actually the software and the algorithms.
Yeah.
And they have a pretty good score on which they
Yeah. Okay.
go on that.
Basically, so there is two things regarding this comparison. So first, you can use panomorph technology and stitch the lens together to create a multiple multiple camera array to capture the full 360 environment. The benefits of using the panomorph technology is you can design the lens distortion according to the position of the camera in the space. That's what I mentioned regarding the back-to-back camera. Now, if we take the example of the broadcast industry, you remember the sports events. We need to do this event in live, and the image coming out of the camera must meet the broadcast quality. So means, as soon as you mix the camera together, the field, I mean the color of the green of the field should be green on the same way depending on all the cameras. And that's the challenge in the stitching cameras, is basically since each sensor is exposed on the different way to the light, the color balance, correction and harmonization is really the big challenge, plus the processing, that preventing for the moment to do it live. So this solution, one sensor, one camera, super high resolution, is really, according to my perspective, the best way to shoot sport event and VR event in live.
How much more expensive is it manufacturing compared to a standard fisheye lens? I assume the geometry doesn't change for every
That's the beauty of this, is compared to a fisheye price point, is quite similar. Basically, there is more difference selecting a manufacturer A and a manufacturer B than the difference than selecting a fisheye compared to a panomorph. So it's really, really similar. The design is, except the secret sauce in the design. After that, regarding the manufacturing, it is really similar.
What are the other applications for this would be in AR? Because right now the kind of AR
Yeah.
solutions that we have,
Yeah.
you can see a lot of artifacts around the edges.
Yeah.
But here, since it's almost too strong,
Yeah.
right? So I see a lot of
That's right. That's right. And that's exactly what I mentioned each time when I meet people and I explain the technology. I can find, people give me some ideas that I never thought at the beginning. So basically, that's exactly what we do. We bring the technology and to let people developing their application and what they want to do with the technology. Yeah.
If you were to buy one of this just for making prototypes,
Yeah.
what would be the price?
Basically, there is many, basically the way we work with the lens manufacturer. So basically, we design the lens for them, and after that, they sell the lens on the market. And there is different lens available from Fujifilm, panomorph lens available from Fujifilm, CBC, for more security space. And in the consumer space, there is manufacturer also in Korea. Yes, exactly. But there is different lenses depending on the application you want to build. And you can go on our website and you have the full list of the different manufacturers producing this type of lens. Exactly, so the SDK is free under license, just to set the IP and protect the IP, but we provide the SDK free of charge to all the OEMs and application manufacturers. Yes?
Have you tried to compress the data?
To compress, sorry? Yeah. Yes. You mean with the marks? Yes, exactly. So we work with different companies for live streaming in the broadcast. And we designed the QR code to sustain the H.264 and H.265 compression. The way that the QR code blocks are designed is to be sure that it will be resistant with the compression algorithm. That's why we pick these techniques to transmit the information. So what I will try in the rest of the presentation is really to pick a case study, an integration case study. So basically, and putting this technology in a mobile phone as a front-facing camera, and to switch for a narrow-angle field of view to a complete half sphere in front of the device to open new use case. So I already mentioned the 360 video chat or video chat on the go, the VR content capture, and also the fashion selfies and group selfies. So that's the use case that the technology brings inside the smartphone. And so I will break down the different integration steps to let you appreciate how an OEM or a manufacturer create a solution with the 360 technology. So basically, everything starts by the scene. Okay, so what we want to do, we want to capture the 360 environment in one shot, a sphere shot, or in a video. So we look at the application and we define the distortion patterns. So in this case, smartphone, it's at the 45 degrees. Then, as soon as we have this pattern, we simulate the image before starting the design. And then we start the design. So we fit the industry requirement, and in the term of the smartphone, that's why I picked this one as well, is the one of the most challenging in terms of imaging technology. So basically, the lens are very small. The lens has a limited materials, so mainly plastic. You cannot play with different materials to bend the light on the way you want. You just have a limited choice of material. Smartphone has a wide range of operation conditions, from bright area outside up to the nightclub with very low light. The sensor must be small, the module must be small, so the pixels are very small. So the sensitivity of the pixel is very low. And since the pixels are small, the aberration in the optic must be well controlled. So that's all the challenge, the technical challenge that the industry bring to the optical design, plus the low-cost constraint. When you replace a component in the consumer industry, you need to be sure that your price point, and that was the question, you need to be sure that your price point will be equivalent to the previous technology to bring the adoption. If you are too expensive, nobody will use it. The biggest, on the other side, the advantages we have on the smartphone is that the CPU, the GPU, and the ASP are powerful. So and the performance are increased each 6 months. The manufacturer releases new smartphone with more horsepower inside the chip, low power consumption. So that's help to integrate the technology inside the device. And with our approach of processing and lens design combined together in the same team, we have the optical designer talking to the imaging guys and say, okay, can I do this? Can I do that? Could you correct this aberration? Yes, no. So it's really they work together to be sure that at the end, the use case and the application will fit the requirement of the OEM. So one example, talking about the 360 scene, is one challenge that the wide-angle capture increase is the exposure. So since you have a very wide-angle scene, you have more chance to have a super bright area on one side and super dark on the other side. So basically, that's where the image quality tuning and all the image processing techniques take advantage, because you have to deal with that more than with a narrow angle camera. So you need to be sure that you will have this processing available to create the best result. So that's an example of panomorph lens for mobile phone industry. So basically the magnification in the mid-zone and with a reasonable size that allow the OEMs to integrate this in very thin phones. You can see the TTL, so the ZI of the lens is 3.8 millimeters. So at the end, the camera module is really similar to what is existing right now in the smartphone. So that's the first stage, is really to design the lens to fit the application. Then after that, as soon as you have the, oh, yeah. Sorry? It's very difficult to hear your question. I'm really sorry, because I catch just sorry for that, but I get just the half for what you are saying. So.
I was just wondering, the fisheye lens, that seems to make more sense for outdoor, because like outdoor environment is kind of 360, right? But when you're sitting in a room, the fisheye lens kind of distorts what could be more reasonable surrounding, right? Yeah. So in that sense, I was wondering if there are any thoughts on if the application is indoor versus outdoor and using like different lenses that way.
Okay, so basically the wide-angle lens captures the full 360 environment, no matter if it's a fisheye or if it's a panomorph. The flexibility that the panomorph brings is the capability to select an area and say, okay, I would like to magnify this area for my application. Now, what you are talking about is more regarding the distortion correction. So basically, you have different type of projection depending the scene. So you're right. If you take, for example, a wide-angle lens and you do the dewarping with the perspective projection and you have close objects, the perspective and the proportion of some object could appear, could be distorted. So that's where the dewarping algorithm must be tuned depending the use case. So to reproduce the regular lenses. So basically, for example, to create a pincushion projection on the dewarping how can I say that? To preserve the perspective and the proportion. Let me show you something regarding this. I have to browse my computer to do your demo, so it will take a long time, but I will show you right after. So basically the goal is really to, depending if the object close or far, you change the projection in real time to keep the proportion. But I will show you that right after, okay? So now we have the lens design and we have the lens. Now we have to integrate the lens inside the device. In this case, in case of the smartphone, you have two options. So basically, if the lens protrudes on top of the surface with a protective dome, for example, you can capture 182 degree or 180 degree field of view. As soon as you want to put the lens below the cover glass, the screen cover glass, as unusual front-facing camera, you have to consider to sacrifice few degrees of the field of view. And that's the difference between those two examples. So in this case, the lens protrudes by 100 micron on top of the screen surface. And in this case, the lens is below the cover glass. And depending the size of the aperture, all on the cover glass, you have more or less field of view in between 165 and 171. So you have some images on the bottom with the red circle showing what is the part of the field of view you sacrifice if you go below the cover glass. So as soon as the lens is inside the device and the electronic connectivity works well, we have to modify the Android stack, software stack, to host this new processing and this new software, this new camera module, sorry. So starting from the drivers, the sensor driver, then the ISP tuning, then after that integrating the processing, if you remember the marking and the dewarping deeper inside the device in the camera hall to ensure that all the legacy application will be able to use these new cameras. After that, creating the API for the software developers and application developers to pilot and to modify the distortion, modify the 360 navigation for the different apps, and at the end providing to the OEM a set of turnkey apps using the technology. So I will pass through those different steps. So basically, regarding the driver customization, it's just few modifications. The first one is really to read the parameters from the modules and crop the image on the proper way to keep only the useful area. So in the case of the mobile phone lens, we have made the image circle, but the sensors are usually 4:3. So we crop the image around the circle image to keep only what is interesting. So that's essentially the modification regarding the sensor driver perspective. The the most, I would say, demanding step is really the IQ tuning. It's not specific to the wide-angle lens. It's really all the time, as soon as you release a new device and you create a device, the IQ tuning is the most demanding task. You have to calibrate the sensor in different light conditions to be sure that the image will be good in a nightclub, outside, inside. So it's really a long process to tune the ISP to process the image properly. And what is really interesting working with different OEMs is it's really related to the OEM taste. So some OEMs do like the true color, so means the image should appear as your eyes would see it. The other want to increase the blue of the, when you go to the ocean and you capture the ocean, they want super bright blue for the ocean, super bright blue for the sky. So it's really, each OEM has his own taste for their product, and you need to fine-tune you need to do the tuning according to their taste and the SoC they select. If it's a MediaTek, Qualcomm, Intel SoC, the way to tune the image is different. So that's, I would say, one of the most demanding action. After that, this is the modification of the software stack. So this is a quite indigest. I'm sorry for that, but it's an overview of the image processing pipeline in Android camera roll. So starting from the sensor buyer up to the image, and basically there is a long different step of processing. And what we do in collaboration with the OEMs, we integrate the dewarping processing and the marking processing in the Android camera roll stack to be sure that it's processed at for all the application on top of this. Plus, in this code is really hardware dependent. So Qualcomm has its own implementation of the camera roll. Marvell has its own. Intel has its own. Samsung, I'm sure, has its own as well. And so basically, we have the possibility to play with the SoC vendor code to leverage all the potential of the application processor. Going on GPU, DSP, creating some memory shortcut between the CPU and the GPU to accelerate the processing. So that's, from a software engineering perspective, that's it's a really interesting task. After that, the application layer. So basically now it's ready, we receive the full 360 image and we create different use case for this new technology. So basically in this case, it's more or less a Google camera app revamped towards the sphere shot camera and sphere video sphere video use case. So basically, instead of just capturing photo and video, we allow also to create different views, zoom inside the image, creating the groupie, the fashion selfies. So it changed the user experience without changing the user habit to use the camera. The other application that we put on top as a widget on any video chat application is the 360 navigation piloting. So basically when you start a Skype or QQ or WeChat, a widget appears and allow you to select the point of view you want to broadcast through Skype. The phone do not broadcast the full sphere. You could, but the use case is really the phone create the view that you want to broadcast to Skype. For example, a super interesting use case we developed is you are doing a video chat. So the front captures your face, and no matter the movement you do with your phone, you are always in the image. So we use techniques like phone orientation, plus optical flow, plus face tracking to focus the attention on your face and broadcast only your face. And it's like the end-free video chat. I don't know if you remember when we bring a speaker it's not me, but when the industry bring the speaker in the phone, we move from this to this. And now you don't see too much people doing video chat in the street because it's quite impossible to walk, hold your device like this, and communicate in video. With this technology, we'll see more and more video chat, even video chat on the go, because it's like an end-free video chat. I could do a video chat from my phone in the same time that I do something else, cooking, walking, doing a talk at the conference. So basically that's opened a new way to communicate to people, putting this technology inside the smartphone. The last app, the last use case is really the VR, what I call the light VR experience. So basically, from your phone, you capture a 360 image, you can share it, but you can also explore and be immersed in the scene that you have captured directly from your device. So let's say that last week you were on vacation and you had a nice landscape or nice experience, sound plus 360. You can put your VR glasses on top of your device and we enjoy this experience directly from your phone. That's another interesting use case. So that's conclude the case study of the integration case study inside the device. Do you have any question or any remarks about this part of the presentation? Okay, thank you. So for me, this is existing. You haven't seen it, it's not announced, but this is existing. Everything you have on this cloud image is existing. So what's next now? So what 360 can bring to the industry and to the consumer industry? So this year there is two big trends. So the VR, we covered this, but the next, the other big trend is the IoT, Internet of Things. And I know that you are at the edge of the industry, so you will understand what I mean. So basically, now the devices are connected, so they are talking each other. You can pilot the device from your smartphone, creating different user experience. But when they will become smart, okay? When we will have the device understanding us, catching our habits, catching our moods, and to become smart, I'm really convinced that they need the vision to understand, to have the full context awareness, and understand and react in terms of according to this context. So, from my point of view, the 360, you will see more and more 360 vision in the IoT. So basically the house reacting according to what you do using 360 vision sensor. Any thought, remark, idea? Thank you very much for attending this presentation. That's my first time here, and I'm really happy to have this large audience. Thank you, Tom, for the introduction and to have made this happen. Don't hesitate. I have some demos that if you want to come here after that and see, for example, a smartphone, a reference design of smartphone integrating the technology, or a few demos on the computer, don't hesitate to come.
So thank you very much, Patrice, for a very interesting tutorial. happy to see on the last afternoon of the conference so many people coming to the tutorial, which I think speaks for the both for the subject matter and also for the presentation. We do now have time for questions, which we can certainly hold now before Patrice shows any demonstrations in a smaller group up here on the stage or on the side. Are there any questions or comments?
I would love to have your comments, good or bad. Don't be shy. If you have something to share, don't hesitate. I'm here for that because I don't want to just push you my things. I want your feedback. That's most important for me.
It's a very nice presentation. I'm just curious, have you looked at any of the multi-camera on how it would change your lens design for using, say, 4 or 6 cameras integrated together and stitching them?
This is not us. We had a lot of requests from OEMs to assist them to create their solution like this. Basically, how to design the panomorph lens with this application in mind and control the distortion to have the best results. There is different strategy depending the location of the camera on the device, and you can adapt the distortion to make sure that at the end you have a smooth, homogeneous quality across the full 360 by 360 field of view. That's the most important, because when you explore the content, you don't want to have areas where the quality is really good and where the quality is really bad. Your eyes are really sensitive to this. So you need to be sure to design the lens to have a smooth 360 by 360 sphere at the end.
I have a question, which is that you explained how you need to transmit some metadata along with the warped images, so that at the other end they can be de-warped in the right way. Yeah. So my question is, are there any standardization activities going on, and is ImmerVision involved in those?
So basically, there is. With YouTube and Facebook integrating the technology, the 360 technology, we are pushing the adoption also on, and we are communicating with these industries, vendors, to explain the benefits of to avoid the image processing. Because from now, the format that is supported by YouTube or Facebook is a planispheric, so means there is no lens, no planispheric lens. So basically it's stitching plus image processing at the beginning before the streaming, and that's change the image quality. So that's why we propose these techniques, to be sure that what's coming out of the lens on the sensor is the best format up to the display, because you don't process the image, transform the pixels.
What would be the kind of performance figures for doing the debugging and stuff like that?
What is the, sorry?
What would be the performance figures? Like how much time would it take to do debugging? Because I was just opening for the Google driverless car, where it has on the top it has a LiDAR and it has actually a camera to do slap.
Yeah.
So and they have actually visual assisted navigation plus a LiDAR. So of course the LiDAR is obviously much more expensive because it's able to gather millions of data in a second. So I was just wondering how is the performance.
So basically it's really light. So it depends the type of dewarping you want to do. So there is two types. The first type is what we use in automotive industry. So basically it's like we dewarp the image, but on the static way, means there is no interaction. It's dewarp and it's project on a certain surface. And this is very, very light. It can run in an ASIC. After that, when you want to create the 360 navigation, it needs to be dynamic. And that takes more, you need more performance. And most of the time, it's a split processing between CPU and GPU. But right now, on the low end, just to pick an example, on the low end mobile phone, we can process at least 60 frames per second. So it's really efficient and can be available to on any type of phones.
So when you say 60 frames per second,
Yeah.
is that?
It's the navigation. I mean, when you change the point of view. No matter the frequency of the input, 30, 15 or 60, it has to be desynchronized from the capture. So the 360 navigation must be desynchronized. No matter, and that's also what is done in VR. No matter the frequency you receive from the video stream, the movement of your device is, yeah.
Are there snap-on lens attachments for existing smartphones? Do that more?
So you mean the afocal attachment? So yes, there is different afocal attachment with fisheye, not yet with panomorph. Because and that's why we promote more the integration inside the device, because you don't want to carry an extra gizmo, I would say. Even I'm trying to find, I came to the CES to find solution to remove my wallet and my key from my pocket and having only my smartphone. And that's where the industry go, because it's annoying to have your ID, your keys, your wallet, and your smartphone. So I dream the time where I will have everything inside my smartphone.
Which is a large legacy.
Yes,
That they open up the market.
yes, exactly. But now the technology there is just a matter of integration.
I think it's also complicated by the fact that you would have to figure out some way to get some of the accessories additional.
Yeah.
That needed to be required, that was required integrated with the game versus what it is now.
Could you tell us a little bit more about the additional sensor information that you can use to enhance the experience? So I think you mentioned accelerometers and
Yeah.
orientation.
Exactly. So that was the first idea. So basically, adding the parameter essential to do the dewarping on the proper way. But since we developed this technology and we are in contact with different OEM, now we see that OEMs add their own information to drive the user experience. So basically, let me pick an example in video surveillance. So basically, when a camera vendor creates a 360 camera with for video surveillance, they add in the mark the timestamp, the copyright, and the unique ID of the camera. So streaming this to the VMS can use it to display and to create different user experience, also the privacy zone, and that's what the camera vendors are doing right now. So creating this type of user experience beyond the dewarping. And that's also something we promote. We have we maintain a list of tags that the OEM can use and when they create the device, and also the ImmerVision enabled software can read on the other side.
Are there any other kind of sensors that might be used in addition to the accelerometer and orientation?
GPS, altitude for drones. That's the most common timestamp, and the copyright as well. So basically, the surveillance industry do like to identify and to be sure that the video was not touched. It's really important for forensic purposes. So this technology helps to to add more content and more information inside the image. Car industry as well, for black box purposes. So there is many different tags on top of the essential tags for developing.
Good. Well, in that case, let me just conclude the session, and let's put our hands together for Patrice Roulet and thank him for a very interesting presentation.
Thank you very much. Thank you.